Good morning, everybody. We're going to be moving on now into solving multi-step equations. So these are just a natural extension of the equations we've already been solving, which we usually call two-step equations. Now, there's going to be a couple of new skills involved in a multi-step equation. The first one is called combining like terms. So combining like terms is this idea that if they have the same base, then we can combine them into one term. So let's look at an example of what that might look like. So say I have an equation that looks like this. Now, the like terms in this case are the 2c here and the 1c here. Now remember that the term includes the operation in front of it. So these would all be separate terms in the equation. Now I'm going to combine this two c's with this 1c, and when I add 2 plus 1, I get 3 c's. And the rest of it I'm just going to drop down. I'm not going to try to do too much work on one line in the beginning especially. Now I've got all the c's on this left-hand side of my equation here, and I want to try to get all the numbers now on the right-hand side. So my first step should be to subtract this 12 from both sides. Remember, we're keeping our equation balanced by whatever we do on the left-hand side, we're going to do on the right-hand side of the equation also. You know me, I like to draw this little line here. It's not necessary. Now I'm working vertically now. I'm going to subtract 3c, and I'm going to take away nothing from it, so that just leaves a 3c. This positive 12 and this negative 12 will cancel out. I'm going to drop down my equals. The goal is to try to keep these things lined up. It helps the readability of your problem and prevents you from making simple errors usually. And then we have 8, and we're subtracting 2, so that leaves us a 6. And we have a 7, we're subtracting 1, that leaves us with another 6. So now we're down to a one-stepper. We have 3 times c equals 66. We're going to use the opposite of multiplication, which is division. To get rid of this guy, we'll cancel those two out. We'll have a c left. And then 3 goes into 6 2 times, and 3 goes into 6 2 times. And there we have it. C in this case is equal to 22. Now, to check my answer, I could plug this value of c back into my original equation. It probably looked like something like this. 2 times 22 plus 22 plus 12. Does that equal 78? Well, that's 44 plus 22 plus 12. That is 66 plus 12, and that is 78 indeed equals 78. Check. Okay, so not too bad. Combining like terms, remember, is to put all the terms on one side that are the same together into one single term. Now, imagine we have something that looks like this. Let's make it a 16. Subtracting 2b equals 46. Now, in this problem, I see 8b here and negative 2b here. Remember that the terms include the operations in front of them. They are stuck together. So I'm going to combine these two pieces right here, and not including this 16, which doesn't have a b onto it. So 8b subtracting 2b is 6b's. I'm going to drop down the rest of my terms, my equals, and then I'm going to write down the right-hand side of the equation also. Now I'm going to try to get the variable by itself. So this 6b is going to have to wait for now because I need to take care of this guy. So I'm going to subtract 16 from both sides, draw my line. Now I have 6b is equal to 6 subtracting 6 is 0, and 4 subtracting 1 is 3. And now I have 6 times b, so the inverse operation of multiplication is division. and b is equal to 5. We did it. Okay? Alright. Not too bad, right? And if that's all we had to do, then this would be a super easy peasy lemon squeezy section. But there's more to it, of course. Let's take a look at our next situation, and this is going to include the distributive property. So now we have grouping symbols making things a little bit more difficult for us. Imagine this problem. So negative 2 times the quantity b minus 4 equals 12. Okay, there's only one b over here, so that's looking pretty good. I've got parentheses. First step, we need to clear all the parentheses in the whole problem. This is the rainbow property, I like to call it, or the distributive property is probably more people like to call it. That means that we're going to take this whole piece out here, negative included. Remember it, they belong together. We're going to multiply it by everything inside here, one at a time. Negative 2 times 1b is negative 2b's. And negative 2 times a negative 4 is a positive 8. Drop down the rest of my equations, including the equals. And now I'm down to this two-stepper. So I think I know what to do here. I need to get rid of this 8 because I want to get this negative 2b by itself. So the opposite of addition is subtraction. And you know me, I like to draw that line. And then negative 2b is going to equal to 12 subtracting 8, which is 4. And let's go by 2 on both sides. And we end up with b is equal to negative 2. Alright, I think we got that one. Nice. Now, the last thing that we need to worry about is fractions. Because you know no math section would be complete without our friends the fractions. And as we move through this year, we're going to end up more and more in fraction world, and we're going to be leaving the realm of decimals behind for a while, sadly for us. So here we go. We've got this guy right here. 2/3 x plus x over 2 equals 7. I'm going to rewrite this. I'm not a big fan of this x divided by 2. I like to write the fraction in front a little bit, so this to me looks more like 2/3 x plus 1/2 x equals 7, and that just keeps it a little bit more clear in my mind. Well, that's just me. So I have this guy here, and I have this. Whoa, what was that? This guy here. Okay, so I have 2/3 x's and I have 1/2 x's, and I need to combine them. So to make a common denominator, I have to find out what does 3 divide into and what does 2 divide into. So I'm going to take the biggest number and I'm going to start going up. So 3 goes into 3, sure, but 2 doesn't go into 3, so I'm going to go up to the next multiple, 6. 3 goes into 6, yes. 2 goes into 6, good, I found it. So now I'm going to rewrite this thing in 6. And to get the 3 into a 6, I had to multiply it by 2 on the bottom, so I'm going to multiply it by 2 on the top, that's 4. And to make the 2 into a 6, I had to multiply by 3, so I do the same on the top again. 3 times 1, which is 3, equals 7. Now, same denominator, add the numerators. That means that 7 over 6x is equal to 7. Looks a little bit like a hot mess. But remember, we can always get rid of a fraction in front of this variable by multiplying by the inverse. That is just a flipped around version of the fraction. Something special is going to happen over here. These guys cancel out, and these guys cancel out, leaving us with just our friend x here. Now I've got this 7 here. Well, 7 can be rewritten as 7 over 1. And now we're going to cancel on the diagonals again. So life is good. It's my favorite multiplication number, 1. 1 times 6 is 6, and 1 times 1 is 1. I won't even bother writing it down there. Okay, so we did it. Now, let's go for even a more challenging problem, my friends. Here we go. We have 2 thirds x plus, let's just do the same one. I'm going to show you something new. Okay? Now, I know this isn't true of any of you guys, but imagine if I had a bunch of students who did not like fractions, and I could show them a way to get rid of fractions from their problems in one step. I know you're probably not very interested in that, but I'm going to show it to you anyway, just, for completeness sake. And I'm going to multiply the whole equation by 6. Now 6 is the common denominator between all the fractions in the problem. Let's just see what happens. I do it on this side, and lefty righty, I got to do it on this side. So this one becomes 12 over 3x, because that's a 1, and then 6 over 2x equals, well, 6 times 7 is 42. That's a difficult one. Now I can reduce this. 12 thirds is really like equal to 4 over x. Over 4 times x. Plus 6 divided by 2, which is really 3x. And now we have 42. Hey, check this out. Where'd all my fractions go? They all disappeared. Fiate. Now, 4 plus 3 is 7 x's equals 42. And we're going to divide both sides again. We got x is equal to 6. So, the strangest thing just happened. I multiplied by the common denominator throughout the entire problem, and my fractions dropped away. Many people can go from this line right here straight to this line. If you can see the trick, then you're totally welcome to do that. And this might be a way to help you get rid of all the fractions in your problems for a while. So, yeah, maybe play around with that a little bit. Ask me or Miss Tabby for some help on it. Maybe we can give you some tips, tricks. Okay? So let's just reiterate what our strategies are. 1, we are going to clear parentheses on our problems. 1a, we're going to clear those fractions too. Look at that one. After we do that, we are going to combine like terms. Yep, yes we are. And once we've got that, we're going to undo the additions or the subtractions that are left behind. And then the last thing is we will undo the multiplications or the divisions in our problem. Okay? Good luck. I know you can do it, and I will see you all soon.